Alrighty, welcome back, mathematicians. Section 3.3 is all about differentiation rules. So it'd be pretty annoying to calculate the difference quotient or the limit of the difference quotient for every function. So good news is that a lot of people realize there were some patterns forming with different properties and different types of functions. And so now we have all these differentiation rules, which I don't even know if I spelled right. Differentiation. Yes. Cool, I think that's right. So the first one is the derivative of a constant function. And I highly suggest when taking notes for this section, take notes as you usually would, and then to the side, make a derivative rule like chart or like cheat sheet, because it's really useful to go through homework problems and examples and recitation with Bailey if you if you already have that sheet with you, so you don't have to like, oh, I think this derivative rule, it works like this, and you get part of it wrong, and now that's kind of stuck in your head. So it's easier to just have that cheat sheet with you and kind of ingrain these rules in your mind so they become like second nature. So the derivative of a constant function, some of these graphs are pretty easy to see kind of what the derivative is going to look like. So if we have a constant function, not gray, that's just some line, right? So, and it's a straight horizontal line. So we say that if f of x equals c, where c is a constant, so we just call that guy c, then what's the slope of that line? We say that dx of f of x is going to be equal to dx of c, and that slope is just 0, right? Slope, if we think about of a line, is rise over run. I'm not rising at all. I rise 0, and I'm running over the whole domain. So 0 over any number, it's going to be 0. All right? So any horizontal line is going to give me a slope 0. Whoa. So we also have a really important one called power rule. So remember we talked about power functions, like x squared, x to the negative 1/4, x to the 3/2, right? A variable to some number, different than a number raised to a variable. Remember that. So power rule says if n is any real number, the derivative with respect to x of x to n is going to equal n times x to the n minus 1. So my exponent is going to come down up front and be a coefficient, and then I'm going to subtract 1 from the exponent, right? So this is also for all x where x to the n and x to the n are defined. All right, so let's do a few examples. So we're going to find the following derivatives of f of x, g of x, and h of x. So f of x is going to equal x cubed. Therefore, f prime, that 3 is going to come down front. So 3. And to replace the 3, we're going to do 3 minus 1, which is 2. And we get 3x squared. I almost said cubed. All right, so then g of x equals x to the 2/3. So g prime of x is going to equal the derivative of x to the 2/3. So now my exponent is 2/3, so that's going to come up front. 2 divided by 3 times x to the 2 divided by 3 minus 1. 2/3 minus 1. Let's do that. Minus 3 over 3. It's negative 1 over 3. Alrighty? So I'll have 2/3 x to the negative 1/3. Remember how we can rewrite something to the negative exponent? I can take this 2/3 times 1 over x to the 1/3 and then combine those fractions and it'll look like that. You can even take it one step further. Since that's 1 over 3, you can write that as x to the cube root. So whatever your preference is, all three of these are the same and perfectly, oops, not that one because you are missing a 2. All perfectly acceptable answers, okay? So now h of x equals, what did I make it equal? 1 over x to the 4th. Okay, so I don't know how, this is, I'm only defined by x in the numerator. Now I have x in the denominator. Similar to what we did in g of x, g prime of x, how we moved x to the negative 1/3 from the numerator to the denominator and made the exponent now positive. We're going to do the same for h of x. So x to the 4th, 1 over x to the 4th is the same as x to the negative 4th. Remember, we saw that in exponential rules in chapter 1. If that's still confusing to you, you really need to review. So h prime of x is going to equal the derivative with respect to x of x to the negative 4th, which is going to equal negative 4, x to the negative 4 minus 1. It's not negative 3, it's negative 5. Okay, I see a common mistake of making that a negative 3 instead of a negative 5. Negative numbers get bigger when you subtract 1, okay? So then, in your textbook, this rule is called the constant multiple rule. I don't like calling it that rule because it confuses it with the constant, derivative of a constant. So I call this coefficient rule. We also called it the constant multiple rule and limit law. So if u is differentiable with respect to x, and c is a constant, then the derivative with respect to x of c times u is going to be the same as c times the derivative of u with respect to x. We can also just write c times u prime as well. Basically what this means is I can pull out the c, take the derivative of u, then multiply by c again. So basically the constant's not going to change. The coefficient's not going to change anything. I don't want you guys to get confused with the constant rule because the c isn't going away to 0. It's staying there. So think of it as it came with a date to the party. It came with u to the party. So after midnight, he can like stay. If c comes to the party alone, sorry, he has a curfew, he has to go home, okay? So let's do a few more examples. We're going to do a lot of examples this chapter. So if you notice, this is pretty similar. The derivation of this rule, it comes from the limit laws. So remember, if I had some k times something, the limit of that is just k times that limit. So we're going to find y prime when y equals 3x squared. So y prime is going to equal the derivative with respect to x, 3x squared. I can pull that 3 out and just focus on the derivative of x squared, which we know from power rule is 2x. And then I can multiply that 3 back in. And that's how I get 6x. Okay? So we'll go into more examples of this as we add on more rules. So another one, I think this is number 4. They kind of go together. So sum and difference rule. This one says if u and v are differentiable, their sum and difference are both differentiable. I'm going to write differentiable DIFF. Just, it's a really long word to write, and I'm going to be writing it a lot. So we say that d dx of u plus v is going to equal du dx plus dv dx. You can also just say u prime plus v prime. Alrighty, so then d dx of u minus v equals du dx minus dv dx, which is equal to u prime minus v prime. The difference rule is actually derived from the sum rule and the coefficient rule. So if I combine that, v technically has a -1 as its coefficient. So that -1 hangs out there. It came with v to the party, so he can stay. Okay? So a fun example of that, we're again asked to find y prime when y equals, what does it equal? Where'd it go? Oh, here it is. X to the 4th minus 2x squared plus 2. No, just kidding. Not that one quite yet. We'll do that one in a second. x to the third plus 4/3 times x to the squared minus 5x plus 1. All right, so y prime is going to equal d dx of x cubed plus 4/3, because that's a coefficient. I don't care about him right now, but I know he's just going to stay. And take the derivative of x squared minus 5, because he is a coefficient, derivative of x with respect to x, plus derivative of 1, because he is a constant. Alrighty, so power rule says that x cubed's derivative is 3x squared plus 4/3 times the derivative of x squared, which is 2x, minus 5, x's derivative. X is technically x to the 1, so that 1's going to come down, x to the 0, plus derivative of a constant is 0. When we're talking about x to the 0 here, 1 times x to the 0, that's just 1 times 1, which equals 1. So the derivative of x is just 1. Alrighty? So I can simplify this. Yeah, y prime will equal 3x squared plus 8/3 x minus 5. Perfect. So our next example, we're asked to find when y equals x to the 4th minus 2x squared plus 2 has a horizontal tangent. Oopsies. So what's the slope of a horizontal tangent? Horizontal line. It's 0. Right, remember we can't have vertical tangents, but a flat line, it's pretty level. I can walk on that. Horizontal tangent, it's when the slope is 0. So we want to find x when the derivative equals 0. So first we need to find the derivative. So y prime is going to equal the derivative with respect to x to the 4th minus 2 times the derivative with respect to, I don't like how I wrote that, x squared, and so on. So then x to the 4th, that 4 is going to come down. 4 minus 1 is 3, minus 2 times 2x plus 0. So we get 4x cubed minus 4x. So remember, I want to find when this y prime equals 0. So I'm going to set 0 equal to 4x cubed minus 4x. I'm going to factor out a 4 and an x at each term, so I'll have 4x times x squared minus 1. So that means that either 4x equals 0 or x squared minus 1 equals 0. So solving each one of these equations, I can get, I'm going to divide each side by 4. So I get 0 equals x, 0 equals x plus 1, x minus 1, so x equals 1 or negative 1. So those are just my x values. If I wanted to find the points along with them, I need to find their y's. So negative 1, 1 minus 2 plus 2, 1, 0, 2, and 1, 1 is all where y equal to x to the fourth minus 2x plus 2 has a horizontal tangent, right? So I found y prime. I took its derivative. Well, I took y's derivative to find y prime. And then I set it equal to 0 and I factored. I know how to do all that from algebra. And we're good to go. Alrighty. So, what number are we on? 5? Yeah. So the fifth derivative rule is the derivative of e to the x. Right, and that's the natural exponential function. So, kind of a fun fact, I think I mentioned when we talked first about exponential functions and e to the x, the natural exponential function, its derivative, interesting enough, is itself. E to the x's derivative is e to the x. So we're taking the derivative with respect to x here. So I don't want you to get too comfortable with this derivative because we're going to learn some more information about it later on. But e to the x, I take its derivative, it's e to the x. All right, so we're going to work with more examples, but just kind of focusing on e to the x. If I have y equal to 2e to the x, and I'm told to find y prime, well, y prime is going to equal 2 times the derivative of e to the x, which is just 2 times e to the x, and we're done. Okay, we'll work more with different versions of this once we know 2 more really important rules. So our sixth rule is product rule. Product and quotient rule are not going to work the same as limit laws did, how I can just take the derivative of the 2 functions, multiply together, and just multiply those 2 derivatives together. No, not true. Do not do that. So if u and v are differentiable with respect to, that's what WRT means, x, then so is their product. UV. So we write d dx uv equals the derivative of u with respect to x times v plus u times the derivative of v with respect to x. Basically, I'm taking the derivative of one, keeping the other one the same, plus, and then I keep going on like that, right? We will also sometimes write with f and g of x. So if I have like f times g prime, that's going to equal f prime g plus g prime f. All right, let's do an example. So find y prime when y equals 1 divided by x times x squared plus e to the x. So I like to do is call one of them f and one of them g. So let's call f of x 1 over x, and let's call g of x the other one, x squared plus e to the x. So we need to find f prime and g prime. So f prime of x equals, this is just x to the negative 1 So -1 comes out, I get x to the -2. And I can rewrite it as -1 over x squared. Okay? And then g prime of x squared, its derivative, plus the derivative of e to the x. So we're going to get 2x plus e to the x. Awesome. Now we need to combine these. So y prime is going to equal, the good thing about product rule is addition and multiplication are what we say commutative. A plus b is b plus a. So it doesn't matter which order I write them. It will order in a second when there's subtraction, okay? So we're going to have f prime of x times g of x plus g prime of x f of x. And that's going to look like -1 over x squared plus e to the x plus 2x plus e to the x times 1 over x. And we can even go on and just simplify a little bit more and multiply this out. So multiplying -1 x squared times x squared plus e to the x. So then I'll get -x squared over x squared minus e to the x over x squared plus 1 over x times 2x is just 2x over x plus e to the x over x. So that's supposed to be x squared right there. These cancel out, giving me a -1. These x's cancel out, leaving me with that 2. So 2 minus 1, give me 1, plus e to the x over x minus e to the x over x squared. I'm perfectly happy with this guy right here, but it saves yourself a lot of time to type this, but I understand taking a quiz, taking an exam, one might be easier to type than the other. So yeah. Okay, so quotient rule is number 7. Of course it is. So again, if u and v are differentiable with respect to, that's what WRT means, x, and v of x does not equal 0, then their quotient is also differentiable. So this one's a little crazy. So d dx of u divided by v equals v times du dx minus u dv dx all over v squared. All right. We also write f divided by g prime, or let me write that with some x's. Oopsies. So yeah, f of x divided by g of x prime will equal g of x f prime of x minus f of x g of x over g of x, come on, squared. Okay, cool. So this one, order matters because there's that negative right there, right? So this negative is very, very important. So here is a big tip for you guys to remember this. So if we write this quotient as, I always write it upside down, high over low, high being my top function, low being my bottom function. I know this is not how you spell high and low, it's just cuter with 2 letters. So its derivative is going to be low d high minus high d low over low low. Right, low is low times low squared. Low d high minus high d low over low squared. Right? D high, if it wasn't obvious, it's the derivative of high, and d low is the same for low. You can also write it low d high minus high d low squared. There's some cute little like thing with like, I think it's like the 7 doors and like high d low d high, like something cute rhyme. I don't know that. You could probably Google it. I just think the low d high, that's how I always say it. If you hear me whispering it during examples, you probably will, then that's what I'm saying. Okay? Get rid of this cute pink. What a good color. Okay, cool. An example. We're going to do 2 examples for this one because there's going to be some places where you don't always think quotient rule is. So, or where we can use quotient rule. Okay, so we're going to find f prime of x, haha, switching it up, when f of x equals x squared minus 1 over x cubed plus 1. Okay? So f prime of x is going to equal yeah, so low is going to be x cubed plus 1 times d high, so we can write x squared minus 1 prime, or even, here, let's do it, d dx of x squared minus 1 minus high d dx of low x cubed plus 1 all over x cubed plus 1 squared. Okay? So x cubed plus 1, just going to hang out there. The derivative of x squared minus 1 is going to be the derivative of x squared, which is 2x, minus the derivative of 1, which is 0. So I'm just going to leave it as 2x. There's like a hidden minus 0 there, but don't care. And then x squared minus 1 stays the same, and now it's x cubed plus 1's turn. So that's going to be 3x squared. And then 1's derivative is 0, and we don't need to add that in there. All over x cubed plus 1. You can take it a step further here and simplify, only for the purpose of just kind of making it easier to type in some stuff. All these parentheses. So let's multiply out this 2x in the first term. So I'll get 2x to the 4th plus 2x minus 3x to the 4th plus, because that minus is minus times a minus, so plus 3x squared over x cubed plus 1 squared. So then, what is that? Negative x to the fourth, because 2x to the fourth minus 3x to the fourth will give me negative 1x to the fourth plus 3x squared plus 2x all over x cubed plus 1 squared. Beautiful. Okay. Was that the right answer? Yes. Beautiful. Okay, cool. And that's your answer. Not too terrible, but we plugged into our formula, we simplified, and then we got there. Only took about 4 lines, but practice makes perfect with these. Okay, so our second example, we're going to find y prime when y equals e to the negative x. What? That's not a quotient? What? How am I supposed to use quotient rule when I don't even have a quotient? Make a quotient. So, y equal to e to the negative x. We know, because we're super good with our exponential rules, that this is 1 divided by e to the positive x. All right? So, we can make f of x equal to 1 and g of x equal to e of x, meaning f prime would equal 0, derivative of a constant is 0, and g prime of x would equal e to the x. And then you can plug and chug from there. So y prime is going to equal f prime of x, g of x, minus g of x, g prime of x, f of x, oopsies, over g of x squared. Okay? So then f prime of x equals 0 times e to the x minus e to the x times 1 over e to the x squared. So then this gives me just negative e to the x over e to the x squared, which simplifies to negative 1 over e to the x. Which then we can even go a little further. This might not look like simplifying, but I can write this as negative e to the negative x. And the only reason I'm writing it like this is because we are given y as e to the negative x. And this will be more useful down the road. You'll see in later sections that most of the time you will be giving me an answer like this. But I would love an answer like this so much. Okay. Quotient and product rule. I only showed you for when I had 2 functions. Quotient rule, you can only have 2 functions, but product rule sometimes can have 3. So let's do an example. So we're going to find y prime when y equals e to the 3x. Okay? So notice that y is e to the x, e to the x, whoopsies, times e to the x. I have 3 functions now. They all happen to be e to the x, but still, 3 functions. So we had, let's call this one u, v, and z. Well, I know for normal product rule, u times v prime is u v prime plus u prime v. What about if I have u, v, okay, those 2 look the same, u, v, and z. Notice that in product rule, one function gets its derivative taken at a time. So we're going to have u first, so u prime v z plus u v prime z plus u v z prime And that follows for any number of terms, functions, whatever you have multiplied by each other. So that means that y is going to equal e to the x times e to the x times e to the x plus e to the x, e to the x, e to the x. Remember, e to the x's derivative is just e to the x. So this one is technically u prime, b prime, and that last one is z prime. Whoa. Alrighty, and we can simplify that to be 3 times e to the x, e to the x, e to the x, which is just 3e to the 3x. Ta-da! Okay. So, what if I take the derivative of the derivative? What does that mean? So we also call f prime the first derivative. We then can call f double prime the second derivative. We can write this a few ways. So f double prime of x, we can write it as the derivative with respect to x of the first derivative, which simplifies to d2y dx squared. Also y double prime and d2 of x, f of x. All right. So usually once we hit the fourth derivative, we're not going to have like 100 primes. So we say the nth derivative we can write it as y to the n with a parentheses around the n, so not to confuse it with a power, okay? Don't confuse it with a power, or else I'll know that you're not paying attention. All right, so an example is if we're given y equal to x to the 6th, y prime, I know from power rule, is going to equal, not 5, 6, x to the 5th. Y double prime will equal 6 times 5, which is 30, x to the 4th. Y triple prime, what's 4 times 30? 120. X to the 3rd. We can get y 4th. That equals, I think, 360, x squared, and so on. I'll keep going, and then eventually I'll get 0. And so whenever you're asked to find the second derivative, you have to find the first derivative first, because second derivative is the first derivative's derivative. Okay? So that's it on differentiation rules. Email Bailey or I if you have any more questions. If you have any questions for him that you want him to specifically do during recitation, take a peek at your homework and let him know. All right, I will see you guys tomorrow.